we are going to finish the 1.2 Part 3 notes. We talked yesterday about even and odd functions. Remember the algebraic relation. Even is f of x equals f of negative x. Odd is f of negative x equals negative f of x. Also remember symmetry. Symmetry across the y-axis versus symmetry across the origin. Asymptotes. We talked so far about vertical and horizontal asymptotes. Vertical asymptotes were denominator equal to 0. Horizontal asymptotes are where's the biggest power? Is it on top or is it on bottom? Okay, and we worked with those. And I gave you a horizontal and vertical asymptote example. And then I said, okay, let's look at the graph because I want you to kind of see how the graph works. Now, end behavior. I'm going to tell you, end behavior relates to horizontal asymptotes. If I go back to this problem, end behavior is, okay, what is the graph doing? Okay, Logan was talking about infinity, right? What is the graph doing as it goes off left to negative infinity? And what is the graph doing as it goes off to the right? Okay, so like for instance, this graph had a horizontal asymptote. This graph was going to, off in infinity, it's going to follow the y value of 0. Okay, so the horizontal asymptote overlaps as in behavior. Now, as we look at this one, okay, official wording here, in behavior is what's happening on the far left and far right of a graph. If there is a horizontal asymptote for the function, it will be approaching that number. If the graph is going to infinity or negative infinity, then it will approach that value. So, as we look at these, what I'm going to tell you here is we're going to think horizontal asymptote. Okay, I want you to think horizontal asymptotes. Now, look at example A. Y equals 3x over x squared plus 1. We're being asked to determine the end behavior. Thoughts based on the horizontal asymptote rules we talked about yesterday? What do you think, Logan?
There is a horizontal asymptote just simply because the biggest power is on bottom.
Okay. Horizontal asymptote because biggest power is on bottom. Biggest power on bottom is x squared. What's the biggest power on top?
X to the first.
X to the first. So since that biggest power is on bottom, okay,
Y equals 0.
we're going to have that asymptote of y equals 0. Okay.
Is that it?
I was just debating. The only other thing I want to talk about here before I move on, 3x over x squared. Okay, that's looking at the biggest powers, right? If you reduce that, what does that reduce to become? Reduce as in, what can we divide out of top and bottom?
An x.
So then it becomes 3 over x, which biggest power is still on bottom, right? But that's the idea that whenever the x is on bottom, we're going to have that asymptote of y equals 0. Okay, if it can reduce to that type form. And I want you looking at that because it does relate to something here as we continue. Okay. So that was A, bigger powers on bottom. B. What do you notice? What do you notice?
That they're the same.
Okay.
So we take the coefficients of the biggest powers.
Okay.
Yeah.
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 Biggest power on top is
X squared.
the 3x squared term. Biggest power on bottom
1x squared.
is the x squared term. Now, we just talked about using the coefficients, right? Well, in that same form, if you reduce this, what can divide out of top and bottom? X squareds divide out, and so you're left with 3 over 1, or in other words, 3. What are the coefficients? The 3 over 1. And so this means there would be a horizontal asymptote at y equals 3. And my graph would be following along that horizontal asymptote at y equals 3. Okay? Okay. C. Y equals 3x to the third over x squared plus 1.
No.
What are the thoughts?
You answer every question.
Okay, but I've answered the first part. I'll let you answer. So my thoughts is that the biggest power is on top, but thus meaning
There is no horizontal asymptotes.
Okay.
good job, Logan. Oh, thanks.
Now, we're not done though. We're not done. Because here's the... Did they just ask me for horizontal asymptote? I said think horizontal asymptote, yes. But
That's what I was thinking.
okay, now we have to, on this one, go a little farther. Okay, so I do agree that there is
So that means it's negative infinity to infinity.
no horizontal asymptote. Okay, I agree there. Think about what is that biggest power on top. It was
3 to the third.
3x to the third. What's the biggest power on bottom?
X to the x squared. Yeah.
X to the second, x squared. Reduce that. What can you divide out here?
And x squared.
An x squared, what's left?
3x.
3x over 1, or in other words, 3x.
So y equals 3x.
So our end behavior is y equals 3x, which, can you visualize the line y equals 3x?
Yeah, it goes up 3 and over 1.
Okay.
That makes sense.
And so this is the idea that there is what we call a slant asymptote here. It's a diagonal asymptote that goes along the line y equals 3x.
What's the answer to C? Slant asymptote.
So the end behavior follows along the line y equals 3x. Now, if we look at this one real quick, graphing the original function, 3x to the third over x squared plus 1. Okay. You have what kind of looks like a slanted cubic graph in a way, yes? Okay. What's happening as this goes in behavior, as this goes off infinitely left and infinitely right, it's not following along a number. If I type in my asymptote, y equals 3x, notice that y equals 3x goes right through the center of that graph. And that's the end behavior it's following. Okay? Now, I want to show you real quick, and then I'll be done.
Hold on, shut up.
Equation 3. If I plug equation 3 here, 3x squared over x squared plus 1. 3x squared over x squared plus 1, part B, looks like this. What's this graph doing as it goes infinitely off to the left and the right? Well, it's going off on that horizontal line, and if you put in a line, y equals 3, you'll notice it's following right underneath that line, y equals 3. Okay? So the asymptotes should make sense. Okay, they should make sense with it. But that is your end behavior. What's your graph doing off on the end? Just because there's no horizontal asymptote doesn't mean there's not some type of end behavior. And that's why we had to talk about the slant asymptote there. Okay. You guys have some time. Hopefully plenty of time. Page 93, 48 through 66 evens to finish this up. Okay? And then tomorrow we actually get to move on to 1.3.